No, see? Yeah, I can hear us talking, but I can't see the screen.
All right, let me know when you see me.
Did you hear something?
All right, you won't see me. You're just hearing me. All right, so we're going to start. So hi, everybody who's here tonight in Miami and everyone that has come out from all over the world. We got a very special guest today, Guillaume. I said it right. Uh, he's going to talk to us about the Go programming language in Docker. Guillaume's been working with Go since some of the very early releases and is one of the very first members of the Docker team and has contributed a huge amount of code to Docker. So this is a really special event for all of us, and I'm going to get out of the way now.
Thank you. Questions already? No? Okay, so as being said, my name is Guillaume Charmes. I have been one of the first developers of Docker. I am now in South Florida with a Citrix system working for Cloud.com. And tonight we're going to talk about Docker and Go, the language that powers it. So, first of all, I would like to small question in the room, like do everyone knows about Docker? Nothing new. I'm just going to make a quick review on what's Docker, how it is, and everything. So the target of Docker is mainly everybody. Everybody can use Docker, and because Docker is so easy, Docker is so beautiful, Docker is so nice that everybody, even the grandma, can use Docker. It's of course mainly for developers. As oh yeah,
What happened?
maybe it's better if we can share the slides.
Oh, this came on.
I forget. Sorry, my bad.
No, did you do it?
So yeah, sorry. So everybody can use Docker, and so yeah, of course it's mainly targeted for the developers and the sysadmins. It supports any language. It's as we can see a bit later, Docker is the container manager. So in the container you can put anything. So it's going to support any language, any database, anything you can imagine that can run on a computer, can run on Docker. So for developers, it's a dream. It can run anything. For the ops, it runs on any distribution. It's going to run on any cloud. It's going to run on Amazon, it's running on Workspace, on Azure, on anything you can imagine. And it's going to run on any machine. So if you have a local cluster of VirtualBox, if you have a cloud, if you have a hybrid cloud, it's going to work the same way. And then for the little plus, how do you convince your company to the one who signs the check to go for Docker? It's because it's much less overhead, it's much more efficient. It helps to consolidate your infrastructure because it makes it much more maintainable and much more reliable, and it gives you much more flexibility to do whatever you need. And of course, it is much cheaper. It is free. It is there is no overhead. There is no hypervisor. It's much better performance. It's all good for you and for the CTO and for everyone. So why? Docker solves a very specific problem, which is resolved by this matrix. As you can see, and I think everyone has the issue at some point in this developer's life. There is an infinity of application, and there is an infinity of platform on where to put it. You never, when you have a Ruby application, you never know if it's going to be on Passenger, if it's going to be on whatever. If you have a Python, it's going to be the same thing, and PHP might be running on a PHP mod from Apache. It can be like on a CGI for whatever. Like it's you have tons of application, you have tons of way to run it, and tons of place to run it from. Another the very similar analogy would be the shipping. Back in the days, you had a lot of things to ship, a lot of way to ship it. Like you could ship a car, you could ship wine, you could ship like porcelain, anything. You can ship anything you want from anywhere to anywhere. And of course, you have plenty of way to ship those. It can be by boat if you come from China and sell from the road on the truck. It's very similar. And so what has been the solution? The model container. It has been an international standard since the 60s, and it is a perfect solution because it's but the container, the one who wants to ship something, but everything he wants, we don't care, he puts everything he wants inside the container, and the one who ships just needs to worry about the container and do not need to worry about what's inside. It's the perfect solution. So it solves everything. Now, the solution for the previous matrix that we saw is location and everywhere is Docker. It's going to be the exact same principle. The developers are going to do everything they want inside the container, and the ops are going to do whatever they want with the container itself without worrying about what's inside. So this is where we see an actual separation of jobs. There is a developer that develops, and the sysadmin that admins. And yeah, there is no more like back and forth, like, oh yeah, but I have this version, or it does not work on this machine, or it was working on another, but it's not working on Azure, or whatever. So Docker solves all this. So what is Docker? Like, how does it actually work? It's I went through that just a bit more. So it runs everywhere, as I said. It's really I like to insist on this. It runs on any version of Linux. It is of course specific to Linux, but no matter what kernel version you have, it's going to work. No matter what distribution you have, as long as you have a Linux kernel, it's going to work, and you can run anything. And there is no inside the container you can run whatever you want, and you can run it on whatever you want. This is the beauty of Docker. So this is the complex part. How does it actually work? Like, how is it possible? So as I say this, you might think about the virtual machines, and you would be right, because it's very, very similar in a lot of ways of virtual machines. It's a virtual machine is a self-contained environment that you can run anything, and then you can run it everywhere. But the virtual machine is going to have a lot of overhead. You will need to have full-blown operating system inside the virtual machine. You will need to have an hypervisor that is going to be to make the interface between what we call the guest operating system and the host operating system. If you have a recent CPUs, and it's going to be very much optimized with like the VT instruction, and like there is a lot of way to optimize the virtual machine, but it's still going to be a huge overhead, not just on the hard drive space, because you need to have a full-blown operating system just to run Hello World in any language. You need to have a full-blown operating system. And even though it's going to be a lot of overhead on the storage itself, it's going to be a lot of overhead on the network side, because it's going to through all the virtual machine stuff, a lot of overhead on the hardware stuff. And Docker has none of those. Docker works on the host operating system itself. It's only one and unique syscall, which is ZNS. It does everything. So, is everyone familiar with syscalls? No. Basically, the syscalls are the lowest level you can do with from a user perspective to the kernel. So an user is going to basically call the kernel of Linux and say, okay, I want this, I want that, I want this. Example of syscall would be read, write, send over the network, this kind of thing. Those are syscalls. These are primitive operation of the kernel. And ZNS is going to be one of those operations. One other very important operation that you must know is the fork. The fork syscall is going to say, okay, I am a process, please duplicate me. And so the kernel is going to say, okay, you are here, and now you are here as well. So it duplicates the kernel. And when you have a shell, when you type a command, ls or whatever, basically what's happening is the shell is going to say to the kernel is going to emit this is called fork. It's going to duplicate itself, and then it's going to execute the process ls. And when in Linux, when you execute a process, it's going to override the caller. So the shell is going to fork itself, and ls is going to override the duplicated process. Why is it important? Is because Docker does very same thing. In Docker, what you want to do, you want to start processes. And by starting processes, I mean you can start hello world in PHP. You can compile a full-blown hyper-complex stack and make it run. You can run anything you want. It's a process-based. It's not operating system-based. It's not full stack based, it's really process based. So your target is going to start one process. I'm going to make an example with Bash. Bash is a simple shell. You want to start Bash. So what's going to happen on the virtual machine side? Let's go back to the virtual machine. I am install VirtualBox. I have to download the full-blown Ubuntu. I run my Ubuntu, and once everything is booted and it takes forever, then I can start my shell, Bash, and I have a prompt. This is fantastic. With Docker, it's going to be always similar. You still need to download the image that is going to start Ubuntu. But what as a difference from the VMs is that Docker does everything lightweight. So the Ubuntu image that is going to run with Docker is what we call debootstrap. And debootstrap is actually Ubuntu stripped from everything. So it has a bare minimum that needs to be run for Ubuntu. So it's very, very lightweight. And Docker is going to run that. And you have your host. Once again, with the virtual machine, you have to download VirtualBox, to download the OS to start something. And here, you still need to have Docker, and you run your Bash, and the Bash is going to run at the same level as your operating system. Why is it important? Because as it's directly on the host, you have the host performances. Your process is going to run with the same speed. The memory access is going to be the exact same thing. The disk access is going to be the exact same thing as if it were an actual process that you were running in your regular host. So if it's isolated through Docker or by itself on bare metal, it's the same thing, and this is why Docker is so efficient and is so fast. Oops. Showtime. We are here for Go. So I'm going to present you very quickly, and feel free to interrupt me if you have some question with the Go code base. If everyone can see, maybe not.
You're gonna have to increase.
Yeah. Do that. Better? It's going to be like this. Okay, so.
Can you go up like one more spot?
I'm sorry?
Maybe just one more.
Bigger?
Yeah, that's good.
Better? Okay. So the Docker is structured in drivers. You have the Docker core that is going to manage everything, but Docker itself is just basically a driver. The underlying technology of Docker is what we call LXC. LXC is the actual process that is going to, it's a software tool that is going to handle what I said just earlier, the setNS. That is the one who is actually going to fork and to set the correct flag to the kernel and to do this. This was true a couple of months ago, and since we developed the same thing in-house, but we're going to skip that because it's a bit more advanced. So we are going to stick with the execution of LXC and this. So in Go, there is a well-used pattern, which is the register pattern. It is used for the drivers on the databases, for instance. But when you might have seen this, you import with underscore. Underscore in Go is ignore symbol. So when you import with underscore, it's going to ignore the import. But is going to run this particular function, which is init. And init, on this example with Docker, is going to register and is going to register itself to Docker. So here I am on a different package. I am on the package LXC, and I'm going to register myself to Docker because Docker is going to well, I don't remember exactly where, but basically, trust me on this. We are going to import this package with nothing, and it's going to register it. To register it. So we don't need to actually use the package, but the package is going to register a handler to Docker, and Docker is going to call it later. So this allows us to have either LXC right now, as I'm going to show you, and later on to have the native implementation that we did, or to have another implementation. We can just choose the same thing, and the underlying implementation, so the driver is going to change, but Docker itself is not going to change. Docker itself is just going to call the handler without knowing what is the underlying driver. So yeah. Also, one very big important thing: Docker Go is awesome. And as I said, Docker is awesome, but Docker would not be as awesome if it were not for Go. Why? Because as I probably forgot to mention, Docker runs containers, and these containers, so you have the image that you download and you run inside. It's very nice, but it's also very self-contained, and nothing can get out. So once you have a full image like Ubuntu, it's nice, you can do whatever you want, but when you have a single process, you might not want to have the full-blown Ubuntu or anything. You might want to have just a process. And in this case, what do? You don't have the libc, you don't have any library, you don't have anything. And that is why the Go comes in, because Go is statically linked, meaning that it's a binary that can be used anywhere, everywhere. And let me see if I must have it somewhere. Just to. Here. As you can see, LDD is a small utility that says the dependency of a binary to be executed. And in this case, Docker is not linked with anything. If I do the same thing, for instance, with ls, you can see that there is a lot of library, and this is due to Go, because Go allows us to do this. This is not possible at all with Python, with Ruby, or with anything. It's much more difficult with even with C, and it's with Go it's as easy as a Go build, and with a small LD flag -d, which is going to say compile everything statically. In the case of Docker, because of CGO and stuff like this, it's a bit more complex, but the idea is the same. It's just Go build for your regular usage, and Go build for a completely static binary. And the completely static binary allows us what? To run in an empty environment, meaning that I don't know if some of you have seen that this week. So some people did a Flappy Bird in assembly that runs on a floppy and that can run anywhere and does not even need an OS. Well, with Go, it's a bit the same idea. It's not as advanced, but if you have just a Linux kernel, no matter what distribution, no matter where you are, no matter what's inside, it's going to run, because it's everything is embedded into the binary, and it needs nothing else. It does not need the libc from Ubuntu. It does not need the gems from Ruby, the Python, whatever. It's really self-contained and alone. And this is thanks to Go. So when we are going to start LXC, the global idea is we call LXC. LXC is going to call Docker. Docker is going to call the target process. So if I want to say echo hello world, it's going to be like this: Docker call LXC, LXC call Docker, Docker call echo. Why? Because once let me make a small demo. Docker. When I did this, you can notice that I am on my book on my Mac. Here it's my MacBook Pro, but I run Docker because Docker is a client server, and the client runs anywhere, and the server is only Linux. It's a virtual machine that is in behind, but I can run on my Mac. What happened when I did this? I'm sorry. Let me do a better example. Like this. Maybe better. What happened when I did this? When I did this, I took the image, so as I said, the debootstrap, so the very tiny image Ubuntu. I started a bash process from this. If I do ps aux, I'm going to list all the process. Everything we can see is one and ps. It means that it's completely isolated, it's completely self-contained, it cannot see the process from the others. If I do API DDR, I can see that I have my own loopback and I have my own Ethernet interface. So when I started, and this is why we need to have Docker inside the container in order to set up the network, in order to drop the privilege, in order to set up what we call the namespace, that is going to allow us to do this. And if I do mount, yeah, my setup is a bit special, but mount is in a production setup. Mount is also completely self-contained, and you cannot see anything from outside. And so LXC is going to create the raw container with nothing inside. It's going to call Docker. Docker is going to do the mount of the actual image, the small image, and the namespace, drop the privilege, set up the networking, and then execute bash. Once I'm in bash, if I do that, OS release, I am on Ubuntu 14.04, but I hope I downloaded it before. Hopefully it's going to be fast. Yes. So now I try to run Ubuntu 12.10. I don't have it. I don't have it locally. It's going to make a request to the public registry, and it's going to run it. If I do the same thing, boom, I am on 12.10. So once again, when I did this, I started a container, I mounted all the file system from Ubuntu, I run the process cat, and I'm going to fetch the /etc/os release from within, with all the PIDs namespace isolated, with all the mount namespace isolated, with all the network stack set up, and start this. It is pretty fast. And if I change to another one, it is as fast, and it did the same thing with a completely different OS. I'm still on my Mac, and there is no override, there is nothing. It's in behind, because I'm on the Mac, it's run on the virtual machine, but everything runs on the bare virtual machine. I don't need any extra override. It's awesome. And let's get back to the code. So once again, Docker is going to start LXC. LXC is going to start Docker to make all the setups. And Docker is going to start the underlying process. So when we arrive here, we are going to start LXC. So we are going to build that the structure. So LXC is pretty simple and straightforward. The ID that we have here is going to be well, because of the color. Just look at the line under where I am. Okay. With the ID. Is just an ID generated by Docker. It's random, completely random. Config path is going to be it's a bit, we don't really care about this. And LXC starts, so takes an ID, so it's random, that we can discard. And everything after the dash is going to be what's going to be run. So here we're going to say to the Docker is going to say, okay, I'm preparing my command, LXC starts with that ID, and I'm going then to give it the init path. Init path is going to be the place where Docker is going to be. Once again, Docker start LXC, and LXC is going to start Docker. So this is going to be the Docker started by LXC. It's going to be that ending path. Basically, it's MaxF. And as you saw, it is completely statically linked, and no matter where I put it, it's going to be in this variable, and the LXC is going to execute it. So no matter what the LXC is going to execute, it's going to work because I am on Linux, and I don't need any library, I don't need anything. I could have an empty container with nothing at all. It's going to work. And the driver, right here, we are with LXC. So yeah, it's a small, so some details for to set up the network interface, to set up the ZMTU with which is a detail of the network interface. We can, of course, when we start, small demo again. I am root, but I can set. You have plenty of options. You can, with Dashu, you can set the user you want to have. So this is with Dashu. Privilege is going to be if you sometimes you want to do some particular operations that requires more privilege than is allowed by default by Docker, because the idea of Docker is to be reproducible. The good thing about this is that because it is completely isolated and because it is self-contained, it can be reproduced anywhere. It can run on my VM, it can run on my bare metal, it can run on Amazon, it can run anywhere because it is self-contained and it is reproducible. Yeah, self-contained and limited, and so anything that runs inside and cannot go outside. With privilege mode, you can grant more privilege, but you can do things that will affect the host, the underlying host. And because you are touching with the underlying host, it's not going to be portable anymore. So by default, the option is default to false, because if you try to set it that, it is very dangerous. You need to know what you're doing, and you should never give an user this ability, because someone with a privilege mode is just like if you are giving the root access to that user. Because it's once you have this, it's very easy to exit to get away from that self-contained jail, and you can do whatever you want. So it is not for production use for the users. It can be used if you have a very particular use, if you want to access the GPUs, if you want to set up your network, if you want to do this kind of stuff that is going to affect the host, but know that it's not going to be portable. Working there is going to be your path where you're going to be. But the interesting stuff is going to be here. So, just one more question. Is anyone have ever developed a shell? No? Okay. So, this is the part where we actually execute the LXC. So before we were just looking at the parameters and building. Actually, each time we have params. So well, params is going to be a slice of string, and just like when you do echo hello world, it's going to be a string echo, a string hello, a string world, and in this case it will be a string, a slice of string with three elements, echo, hello, and world. And this is exactly what we are going to do here. I have my slice of string, and I'm starting to build my command line. And my command line, the command line. So as we saw, like the Dashu, the privilege, and everything. And arrives the interesting part, the lookup. So the first step is going to see like where are we going to do, because when ls is nothing, is the shell is going to do basically. Or where is ls maybe? Yes. It's going to do a where is ls, and then it's going to do /bin/ls, because ls by itself does not mean anything. It's going to look in the path where is ls and then execute it. Lookup path is going to do that for us. Exec is the you can see the import OS exec. It's the standard library. It is very useful, and Go for this has been crazy awesome. It has a lot of tools to help us play with the process, and we play with the low level things of Linux. So once we do this, we look up the path, then we set. See, let me show you. See, C is the exec command. So, to be clear, so here we have C. We're going to call exec.command. Exec.command is going to create an object which represents a process. Perhaps with ... in Go, when you do ... it's going to take a slice and send all the parameters into one. So it's a very efficient way to send multiple parameters. Otherwise, I would have to do params of 0, params of 1, params. I don't know how many params I have, so I don't know how many. And when you do just ... it solves the issue. So the path, we're going to set the path, we're going to put the args as we set, and we're going to start. Start is as easy as c.start. If you want to look at what it's doing, it's a bit more complex. So this is going to be the standard library. And if you're interested, it's always very interesting if you're developing in Go to look up and to go see what is actually done by the standard library. For instance, I am using exec.command. I'm using c.start. Just go take a look and what it's going to do. You can command, as I said, is going to create an object that represents a process. What is that object? It's going to be a CMD. If you see the CMD, it's going to have a lot of fields. You can go to the definition and see the documentation. It's always very instructive to just go and look forward. When you use Go and where you're going to have to use the standard library, it's always very interesting to go see how it's done and what the Go team has done to make it work, because a lot of the issues that you add, there is a lot of chance that they added before you. And so it's always very interesting to go see that. And when we are in start, so start is going to be a bit more low level, but it's always interesting to see that it's going to close the file descriptor. So the file descriptor is going to be, for instance, 0, 1, 2, which is going to be standard in, standard out, and standard air. And of course, after, if you have some networking socket, if you have a lot of stuff, it's going to be this. So you can, if you have a socket, for instance, at one instance, and you don't have it later, you don't know what's going on. When you go here, you can understand a bit more why is this, and that you need to set the flow exec. But this is a bit more advanced. So just my point is, don't be afraid to dive in and to go see what's inside the Go library. And even though it might look a bit tough, it's really not actually. And with a bit more time, you just take line by line and you see it's standard Go. There is nothing crazy about this. You just go. And what's interesting us is the OS start process, which is just here. And we can just see what's going on here, and it's going to start the process, and it's going to set the proc@tr, so which is also attribute to the process itself, and then it's going to start the process, but no from syscall. And so you can see that at the design level, that what the Go team did, they have the OS exec that is a wrapper that is going to handle a lot of stuff to eventually call syscall start process, which is the actual exec that is going to happen, as I said earlier, you fork and then you exec, fork exec. And this is really the underlying. So once again, go look at inside the standard library. It's it's good at the technical side, just if you have the difficulty with Go itself. At the design, on the design level, just like this, you can see like, okay, I have very big stuff to manage. And you can see the different level between the primitives on the OS level. Then you can you abstract them and you make it portable and everything. Always good to go see. So once we started, start is non-blocking. We're going to start our LXC process. Is going to start, for instance, our bash, which himself is blocking, but start is not blocking. What's going to happen? Then we're going to wait. Because when you start a process, we have to wait for the process. Why? Because Docker can be has a very, very nice command, which is attach. So if I go back to my run bash, for instance, here is going to be the process ID. If I do Docker PS, I'm going to list the process, and I can attach. And if I can see, I can type on both. So I can have multiple clients on one container, but I can also have multiple containers. So it's an NN relationship, and in order to handle this, we need to be able to wait on everyone. Because if we don't wait, we are going to exit, and the program is going to exit by itself. In order to be stuck and to be actually playing with bash, we need to block, and we need to wait until bash finishes. In order to do that, we have to call the syscall wait on the process. The issue is that we can do only one process wait at all. However, we have multiple clients. What are we going to do to solve this problem? It is going to be, of course, I'm not going to be here. I'm just going to explain it. So it's an issue of synchronization. On the Linux side, you can do only once a wait, and the wait is going to block forever until you tell it so, and so you can have only one wait for one given process. How do we have multiple clients waiting on the same process? We use a Go channel. A Go channel has a very nice properties, which is that when it gets closed, everyone waiting on the channel is going to be unlocked. So we instantiate a chan. As soon as the system wait unlocks, it closes the chan, and everyone that goes to attach or to do this is not going to actually call the syscall wait, but it's just going to receive on that chan. So it's going to block on the receive part of that chan, and it's going to be unlocked once the system calls the close on this chan, and everyone is going to be unlocked. This is why, by the way, if I go here on the so I'm on the top terminal and I type exit, it's going to both are going to exit because the other one was just waiting for the process to die, and it just works. Well, I think it's a bit much for today, maybe. So, any question maybe? I know I covered a lot of things, maybe not too much consistent, but I try to cover as much as I could. Maybe I've been too fast. If you have any question, I can go back. If you have any question?
I have a question. But repeat the question so I can hear. What are you using the basic testing framework, and how are you creating tests for Docker?
So the question was, do I am using a test framework, and so how does Docker work with under the test case? Well, let's go see. It's so short answers. We are using the standard library test framework. There is we don't use any out there. There is a lot of very fancy test frameworks, but no, Docker uses only the main one. And integration test. We have multiple type of tests. We have the unit test that can be run anywhere and completely self-contained, and that are reproducible at will. And we have other tests that are much more complex, like that deal with the kernel or like with the network and things like this, which we call the integration test. And we can see that here. As you can see here, we have all our integration tests are here, and everything that is specific to the CLI is going to on the integration CLI. So this is going to be the also integration test, and if actually it might be more interesting to run. So as you can see, it's the standard test framework. When we want to test the ECO layout, we want to make sure that Docker actually does what is expected. BusyBox is a minimalist operating system. Basically, it's just one process that is linked and has a lot of feature in a couple of kilobytes. So that's why we are using it for the test. And in this case, once again, what I showed you just before, exec command is going to create the process object that we are going to use. So it's going to call the Docker binary with run busybox echo 123. It's just if I exactly the is going to create a process that is going to do that. Run command without with stdout and stdr. So in this case, it's a small helper. Where when we go see what's going on, you can see that it's opens the stdr pipe. So it's going to retrieve the stream of the error output. It's going to call the IO copy in order to retrieve that stream into a buffer that we hold. cmd.output is going to actually start the command and run the command and return the std out. So when we see cmd.run is actually start plus wait, so it's going to start the process and it's going to wait until it dies. Where output itself is going to do to call this run and send everything into that buffer and return that buffer. And so here we have stdr buffer with all the error output and stdr and out with all the regular output. We are going to simply return this. Here we can see does out is equal to test123. If not, we may put an error. Otherwise, we go through and we say it's everything has been gone. We delete our temporary container and we go. Any other question? No.
Are you guys using referencing any third-party packages? You guys build everything?
Everything is vendored. So we do have third-party packages. One of my favorites being Key or PTY, but everything is vendored. And if we can see the vendor, we can see that it's /src, so its vendor is a Go path. It's very similar to the I don't know if you use the GoDep. It's very similar to GoDep. So we put a Go path into ourselves, and here we can see that we have all our dependency. So we have my favorites being KRPTY, which is a repository to handle the PTYs. GoyaMux, which you use for the REST API, for the HTTP server. The dbus, which is going to be used with systemd. What else do we have here? Docker itself. So this used to be within Docker, but now we moved it to its own sub-repository because it's pretty self-contained and it's going to be as a today I showed you LXC, and libcontainer is going to be the custom implementation of LXC. It's going to be the same thing, but in Go and maintained by Docker. What else? We have a couple of things from CoreOS, but still with for systemd. Go SQLite is going to handle the relationship between containers, because you have when you have a container that needs a database, you can say, okay, this container is linked to the database. It's going to be handled by the Go SQLite. We use the WebSocket for the as an opportunity to attach. So it's very easy for JavaScript application, for instance, to call the WebSocket and to attach just as I did earlier. When I'm like this, I am attached. I run the process in the background, and I am attached to it. And with the WebSocket, it's very easy just to have the same output and your terminal through the WebSocket. That's why we need the WebSocket.
Did you guys build your own tool to update this rendering?
Yes. Yes. It was before GoDep existed, and we have a very cool script that does, and for everything we need, we clone it. We clone it with that with the version we want, and the clone is going to be a simple wrapper around Git and.
And how are you guys handling? How are you guys handling releases yourselves as you publish this?
The release So as everything is vendored, so when we push the code, we don't need any external dependencies. So everything is self-contained, and we use a Docker file. Docker file, I didn't talk about it. It's where it is. File. Docker file is it's going to be the file that that Docker uses in order to describe an image. And in this case, we use Docker file ourselves in order to build. So we are in here. When we do a run, it's just like if we do Docker run. It's going to be the same thing. And so we install all the dependencies. And when we make the release, we call this image. And if you can see, entry point is ActDND. So ActDND is going to be the thing that is going to be built once everything I do Docker build and I do Docker run. This is going to be a run. If wrapper, and to make it short, is going to call release.sh, which is going to generate the Debian archive. Is going to publish to Ubuntu PPA, and with the system the Red Hat RPM and stuff like this. Basically.
Do you know what they're using these days? Like, because the big thing at my job, VMware is pushing like vMotion stuff. Oh, if this machine goes down, instantly they'll move it. Is there any like external, like to orchestrate Docker?
This is a trick question. So Docker by itself is single host based. So it means that it's going to be aware about its own host, it's going to be aware about its own process, is not going to be aware at all about the cluster, about what's outside. For this, you have a lot of different tools that are starting up all around. I think the best one that I know of, might be some others, but the one I like is Fleet by the CoreOS team. CoreOS is basically a very small, tiny Linux. As I said, Docker is self-contained and can run on any Linux. It does not need anything. So why would you need to bother with a full-blown Ubuntu or with anything? CoreOS solves this issue by doing a very minimalist image and with Docker. And they extended their concept, and now they are developing Fleet, which is going to manage a cluster of CoreOS, and CoreOS, each of them has a Docker, and with this you can start one container that is going to be spawned, and you can set, you can tell, okay, I want it to be scaled with 3 hours or something like this, and when you have one that goes down, I don't know if they manage that yet, but it's definitely on the roadmap. When another host goes down, it's going to be with something else.
Okay, so my last question is, you guys were experimenting with this technology in Python before you started.
So the Docker is the direct result of 4 years of experience of .cloud. .cloud, which was a platform as a service, written in Python. It has been a Python shop for a while, and it has been .cloud used everything in Python and developed the container management system in Python. So it's we were playing with the container, because the container itself is not a Python stuff, is not a Go stuff. It's really a kernel thing. So it's written in C, it's directly within the kernel, and it's a kernel feature. So what has been developed in Python is our tools to manage this. And with 4 years of iteration, and with also evolution of Linux, we use more and more features that Linux provided, and it started with the PID isolation, with the Monday isolation, with the Spark isolation, and all this has been done in Python, but it has been built with the platform as a service in mind. So it has been really tied to our platform as a service. And unfortunately, it's you know how it is with the software, that you don't know really how it works, and you make it patches and patches and patches. It's good, but after 4 years of patches and accumulated iteration, it's not that good anymore. And so we decided to start fresh, start fresh and to because now we were at the point where the kernel were mature enough to have stable containers. So it had all the endpoints, all the syscalls, and everything that we needed for was there and working, which was not the case like 4 years ago. And we decided to start fresh, and more important, to start independent from the platform service, and to make it a moving part that can be used by the platform service. And so in order to avoid bad practices as like, oh yeah, but I already got this like a couple of months ago, I have to copy paste and get back to the new code, we decided to change the language, and we went through Go in order to have something that was really self-contained, because before in Python, of course, we needed to have our own environment, and so we needed to build, to boot up, not to boot up, but to start images with all our environment. And when you go from another, when you make an upgrade or anything, it was a nightmare. And with Go, as it is standalone, we could start Docker inside an empty container. And so we started in Go because the first of all was really not to be Python, to start fresh. Another one is that of course Go is hype and Go is awesome, so we decided to go through Go. And the most important one is it is strong type, so it's much better when you develop, and it's statically. And this is why we went through.
Static binaries, syscalls, made it easier.
The syscalls, excuse me, yes and no. So once again, yes, Go is awesome, and there's no question asked about this. But on the syscall part, Go has one good advantage, is that it exposes a raw syscall function. So basically, you can call syscall.raw syscall, and it's going to emit a syscall. So you can call anything you want. The bad part is going to be the standard library lacks a little bit of the kernel structures, like especially on the terminal, on the PTY stuff. Like once you want to deal with, for instance, when you have a screen, when you have this is going to be my TTY. This TTY, on this TTY actually is going to be around a PTY, which is a virtual TTY. And when I'm going to interact with it, when I'm going to press a key, it's going to be interpreted by this TTY. This has a lot of impact, because by default, when you press a key, your terminal is going to display the key. And then if you have a process and like Emacs, is going to display the key as well. Instead, in order to have not 2 times the key, you need what we call the raw mode. And in order to set the raw mode, which is going to be, you type and it's going to be directly forwarded to the process and not going to be interpreted by the TTY, you need to set attribute to the TTY. This is the kernel stuff. This needs to go through a syscall which is called IOCTL, which is the IO control. And this needs full-blown structures, which is of course not the same depending on the OS and the architecture. And this is it has been a bit difficult because Go, it's good because it allows you to do it, but it's a bit tough because it does not have all these structures in the standard library. So you need to yourself go check. When you're lucky on the man, you will find it. When you're not lucky, you will have to go see directly in the header files of Linux to see how the structure is supposed to look like. And after you have to try and to make sure that it's going to work on every infrastructure, because sometimes it's 32-bit, sometimes it's 64, sometimes it's not going to be the same constant names, and this kind of stuff. So yes, it's very good because it allows you to do everything you need. You can do everything thanks to that syscall package. It's not that good because it lacks missing features. But once again, if you know what you're looking for, you can set it up yourself. And just let me show you something. Wow. For instance, this is for the macro, as I was saying. Of course, I have test file, but I have the termios, which is going to be the structure itself that is going to be sent to the IOCTL. And I have the 32-bit version and the 64-bit version. If I look at the 64 bits, I can see that I'm going to use it for Linux and FreeBSD. because both of them are going to use 32 bits. But of course, Darwin is going to use the 64. And so that's why I have both of them. One thing that is awesome also about Go, I don't know if you ever tried to do a multi-platform development in C or C++ or anything, it's just a pain, it's awful. Here, I have something that compiles on Linux, on FreeBSD, and on Darwin, just like that. I just have this first line of the file with the build tag, and it's going to see, okay, that compiles, and it works. I have nothing else to do. I don't have to write crazy make files with the conditions, and it just simply works. And so yeah, so here, for instance, is that those parameters for the terminal, EO and C is going to be like the way the input, the output, and the controller sets. Speed of speed is going to be the speed of input and output. So to make it short, so you have this kind of difference, 32 and 32 bits, but you have also TIOC, which I call it, is not really TIOC, but for instance, on Darwin and FreeBSD, and on Linux, you have different syscalls name, and for instance, and as you can see, before it was, let me get it, 32. I could not mix it because it's across it's cross both. 64. So here only on Darwin I have 64. Here only on Linux I have this, and here it's on the right side is not the same. So I have 32-bit and 64 both, and I have different syscall names. And so once you know what you're doing, it's very easy to implement. And you do something like this. It's very quick, copy paste, change a couple of stuff. Have the first line that say, okay, it's going to be on this or on this. Right now, I have been lucky because on this particular situation, it's the same thing on ARM on 64-bit and 32-bit. But if you want to have it on MD64 here, for instance, oops. And here I wanted to have it on ARM. And you do just like this, and this particular file is going to compile only on Linux and FreeBSD, which is on ARM. If I am going to go on Linux with 32-bit or 64, it's not going to compile because of this build tag. So it might lack of things, but keep in mind that Go is pretty young. It has only 7 years old or something, so it's fairly new compared to old language like C++ that are crazy old, and so it is mature. I think it is stable. It can be widely used in production, but it's true that for more advanced and low-level stuff that are not the most common use case for developers, it lacks a little bit of stuff. But for the general use case, it has everything you need. And even when you want to go very much in depth and into the low level, you can do whatever you need very easily and very cleanly without having to deal with makefile with anything. You don't need to do like your autoconf, your crazy build tools. Like it's just as easy as that, and it compiles with Go build.
Challenges mentioned things. Package that's available. You mapped a lot of this calls already.
Yes, yes. So this is this is a list of what you have. Maybe better if I go just there. Come on, go. Yes, I'm on Darwin. Darwin, yeah. Okay. So yes, Go has a lot of things predefined, but not everything. And of course, it's difficult to have everything, but it has a lot of stuff. And it's it also have a very good doc. If you go to godoc.org, I think you have a lot of syscalls that have been already implemented and that are used widely by the standard library, and you can see to see what you need. Most of the time it works and you don't need to do anything else, but once again, once you do like more advanced programming, more low level, you might need and end up to write your own structures.
So you've shown some of the build tooling that you're able to take advantage of.
Mm-hmm.
Are there other aspects of build or other tooling that have been really pleasant to have?
Yes.
I do have to write an article about all this stuff. See, I'm not texting my wife, I should say. Have you guys also in general used any of the profiling?
Okay. Not with Docker.
Race detection stuff?
With yes, the race execution, yes. It's going to be a bit tough to demonstrate it, but if, for instance, here I do a go build. Go build is going to compile, but if I do, if I want to make sure that the race, nah. Just 1 second. Okay, works. So if I do go run main, this compile, link, and execute my binary. Once again, Go is awesome. So this is compiled. It did this. So this compiles and linked is going to generate a binary Go term and execute it. Now imagine that I have a very complex program and I want to make sure there's no race. I can do something as easy as dash race. And of course, well, it's supposed to work. It's just I have I broke my environment a bit before, but when you do just dash race, it's going to add a lot of symbols into your binary, and it's going to make sure that if you have one variable that is going to be accessed twice at the same time, or actually read and write at the same time, and you use timers for this, is going to panic and tell you like, okay, here you have a big issue, like you have someone who writes at the same time as someone who reads. So and this works with just dash race. If I want to go back with the Go test framework, Docker Go test, and of course when you just do Go, it's as easy as this. By default, you just say this init for the nothing, but with dash v, it's going to tell you what's going on, and you have something like you want to see the coverage, you just add dash cover, and you can see here I have 81% of coverage. And after you have a bit more advanced commands that going to you can extract like you can even display your HTML page and remember the commands with which is going to display the code with colors on where it has been tested and where it has been not. And this is as easy as go test dash v dash cover. On the Go builds, you have something that is that might be interesting at some point. It's a bit Sego enabled equals 0. So this is going to tell to say Go, do not use any C at all. By default, Go is going to use C for the user management to access, for instance, LDAP, to access etc pass WD, to access all this kind of stuff. It's going to use C for the network, for the networking stuff. So when you do this, it tells exactly do not use C. Why is it important? Because sometimes you don't want to embed at all the libc, and you want to have something static. And if you are using the network package and you want something static, with C it does not work very well. So you will have to say, okay, no, I want pure Go. Like this you can do. If the issue is that it is still not yet well implemented, supported with the libc. So you have this is just going to say do not use C, but it's going to use C anyway. And in order not to do that, you have a trick which is tag netgo. And when you do this, it's going to say, okay, I really use C as the Go implementation for Go. And excuse me. Errata. You're right. When you do Sego, it does not use the Go, it does not use C at all. It does not use the C implementation. I'm sorry, my bad. It's not true. But once you, when you want to build something static with Cigo, for instance, Docker use the C library for BTRFS for device mapper, which are the storage drivers. It uses SQLite. So for this, it needs absolutely Cigo. If you, in order to do something static, if you're going to use the C symbols for the network and statically linked over the glibc, is not going to like it. So this is why you want to have dash tags netgo to force the use of the Go implementation without the disabling Cigo. My bad. And this tag is exactly the same thing as files. Here I say the Linux and FreeBSD. When you do Go build, it just Go is smart enough and is good to go. I am Darwin here. I am D64. Basically, Go is going to do that by itself, and here you just add netgo. So here it's going to do it by itself, and when you do # netgo, just like if you add netgo here, and in the actually we can go check that.
So for the storage drivers and all of that, Docker's leveraging CGO.
I'm sorry?
For access to all the storage drivers,
Mm-hmm.
like what is that, AUFS you guys use?
We have a BTRFS, we have device mapper, we have IUFS. IUFS does not use Cigo, it uses Syscall directly, but BTRFS and device mapper use Cigo, yes.
So can I choose when I'm building Docker? Or if I know I'm only going to use AUFS.
You can. Yes, you can. It's pretty recent, but yes, you can. It's not trivial though. But if you
But the binary packages are out there.
the binary are compiled with everything.
They're all CGO based, so there's got to be certain libraries.
Yes, but anyway, you will need CGO. It will always be CGO based, right. Because you have in terms of the storage driver, you also have SQLite. You cannot get rid of Cigo, and it's a good thing, I think. But if you want to manually disable the build of the driver, for instance, if you want to use only IUFS and you don't want BTRFS and the device mapper, you can remove the tags BTRFS and from the Docker file, and when you build, but you have to build it yourself. The release binaries embed everything.
Would you say CGO is also been an advantage?
I'm sorry?
Would you say CGO has also been an advantage?
Yes, yes. So CGO has been a huge point and a very huge advantage. For instance, what I just showed with the raw mode, the terminal stuff, it has been a very long time between the time where it worked and the time it worked properly in Go. Meaning that at first I did not manage to get it to work, and I don't have a lot of hair anymore, so that's why. I dropped it and I used the CGO implementation. So what's going to happen is that in Go you can call C code directly. Let me see if I can find an example. I should be able to find an example quickly.
I've got examples also on the Go blog for CGO. Show you how to bind it to
Yes. Here you can see we have the standard, it's a standard Go package, but here in comments we have Go, C. It is standard C that can be compiled with GCC, that just works. And in order to tell Go to use that, we just use import C, and everything that is in comment above import C is going to be considered as C. And so all this is compiled with GCC and linked at the time through that.
So I've never seen that. I've linked to libraries that have already existed. But you guys wrote C code is right there in the comment.
Mhm.
The import C.
Yes.
And C. And
You
no, that would be C.
never.
Is that using GCC to compile that?
Um,
Standard GCC
yes.
compile?
Yes, this uses GCC, yes. And on the FreeBSD, it uses LLVM.
So they're using the GCC GO compiler?
No. No, this is just for this piece.
Just for these pieces?
Mhm.
Interesting.
Actually, I might be lying. I know we use GCC for sure for the linking, but it is going to be delegated to Gold, and I think we use it. I'm pretty sure we don't use GCC for that.
Sure, I'm sure Go uses.
Because in the Go build you can tell him you can tell to use GCC, you can tell it to use LLVM, but directly with the Go build without GCC Go is like really the Go tools, so it's going to use a lot of things from the Go tools and delegate the rest from the others.
You were using it like from external C files?
Oh yeah, any static, even dynamic library stack, any library that is already on like the Mac OS. Wanted to do something a little bit about CGL will allow you to create bindings to those. But now you have a dependency on that shared library. There's a library being there. So,
And it has to be already found.
well, they're generating it on the fly here. Right? So that code's going to generate library, then they can CGO and bind into. That import C there is going to create the bindings for you. And so you're going to end up
So
with
this is going to end up as library, or is it going to end up as a part of the?
It's part of the build, part of the binary.
Oh, okay.
It's going to probably create a static binary, and then that import C will create a wrapper around it, so that you can use it in Go. But when you do that, you can't cross compile, right? Because now you're targeting.
Targeting
You just
specific
bound
systems.
yourself.
Oh, but he has a build package.
No, they're talking about it. I don't think they got to it in 1.3.
Yes, that's as you can see, this is made for Linux only.
Something that smiles like that.
But
Smile build.
no, it might be possible at some point to cross compile with this, and actually you can cross compile with this when you have, but for this you need to have the lot of crap on your environment, and it's difficult. You don't want to do that anyway. Well,
But this cross compilation stuff is for the developers working on it, right? Because in the when you use Docker in production, it's always Linux, right?
for Docker, yes, but here we are talking about Go, and you might want to have, and for instance, Docker is cross compiled, and if you
We dev on the Mac, but sometimes we boil it in.
Yeah, exactly. That's what I'm
if I do actually, if I come.
Which brings me to another great question. So this code, I can compile this code.
Hopefully it's going to be yes, perfect. So you can see, so this I'm going when I run the Docker file is going to run a ton of. So here you can see there is 24 Docker commands, and this is just because it's described into the Docker file. And when I do this, of course, I need to stash. It is as Docker is smart. And once again, this is a very good property of the self-contained property. When because it's self-contained, you have an origin, you have a modifier, so you know the result because is it reproducible. So you know that if you apply a certain modifier onto a certain origin, it's going to be the same thing here. So meaning that
it doesn't have to redo the steps.
the first time I run that, it takes like maybe half an hour. Here I did it in front of you, it took like 10 seconds. Because it's just going to see, okay, I have this origin, I have this command, I'm looking into like, did I do that already? If I did it already, I don't need to redo it again. Because it's self-contained and it's reproducible, and so I'm just going to use the cache. And as you can see here, I am creating the binaries for the Linux 32, Linux ARM, Darwin, FreeBSD, and everything. And so it compiles on all these platforms. and it works everywhere.
But
But the small trick is that Docker, as you said, does not work anywhere else than Linux. But when, as I said at the beginning, I am running on my Mac and I'm using Docker because it's just a Docker client. It's just
the other versions.
Mhm.
Yeah, so I want you to talk to that because I think it's important to show that you guys didn't just say, well, we're not going to work on Windows, so we're going to ignore it. We're not going to build it. Let's say this platform, we're not going to support it. So how did you guys handle that? You stubbed out some functions for different OSs.
Yes, let's go see that.
So this is one of the advantages if somebody go build.
Yes. Systems. So yeah, here for instance we have our package systems that is going to be wrappers around syscalls. So when the syscalls are too much low level,